Hi guys, welcome to Inside Tuesdays, navigating the world of observability. From the last two Tuesdays, we talked about observability basics, logs, and metrics. Today, we'll talk about the third pillar, that's tracing. Just for an overview, logs help you to record the events, metrics help you to quantify the events. Now, tracing will help you to track the request flows. That was it in the nutshell. Now, let's get started. Going over to the agenda, we will talk about tracing and its types. Then we'll talk about distributed tracing and how it works, and the challenges faced when we are implementing tracing from an active perspective. And then we'll talk about a very powerful tool or framework that is OpenTelemetry. So let's get started. So in the context of observability, tracing refers to the practice of tracking and monitoring the flow of requests as they move through various components of a system. It helps developers and systems administrators gain insight into how different parts of a software application interact with each other. Especially when you're dealing with a distributed or microservices architecture. So it is very useful in cloud native environment. Now, tracing allows you to follow the journey of a request from its initiation through all the interconnected services, databases, and external dependencies it interacts with. So you can understand from the last two videos, we talked about how these flows and how these small details help us to debug and troubleshoot your problems. Now you can understand how tracing adds up to it. It provides a detailed view of the entire transaction, making it easier to identify performance bottlenecks and understand the cause of issues. So the whole purpose of observability is to track those issues and mitigate the risk that we can have in security. If we talk about it in simple terms, tracing is like creating a map that shows the path a request takes through your system. It helps visualize and understand its journey for better performance analysis and troubleshooting. So it's like providing breadcrumbs so your pet can come back home. Now, how tracing differs from metrics and logging, because basically all of these are pillars of observability, but there's some difference in the scope, granularity, and use cases when we talk about them separately. So tracing basically focuses on a specific request journey through the system. So it provides an end-to-end perspective, whereas logging captures events and messages across the application. If you see how errors logs are there, and while metrics provide aggregated quantitative data about system performance. So in the last two videos, we saw how these things looks, right? How logs look and how metrics look. So you can create a picture in your mind that how these are different. And in today's video, we'll also see how traces look in real time. Talking about the granularity, so tracing offers detailed insight into the flow of individual transactions, showing the timing and interactions between components. Now, how this helps when you see how these time tracks, or what do you say, these spans, if you have added a span for a particular application and you know how much time it takes, and if it's taking a lot of time there, you can click it up and you can see that yes, this might be creating a bottleneck or a problem when your application is in the flow. Whereas logging only captures discrete events, and metrics provide aggregated, summarized information in visualization. So, talking about the use cases, tracing is valuable for understanding transactional behavior, identifying bottlenecks, and optimizing performance. Of course, logging and metrics also helps in optimizing the performance, but it's mostly post-active, and this is a proactive approach. So logging is basically essential for debugging, error analysis, and historical context. So in a way, it has already happened, and if you see the traces, you can actually reduce the time and load of an application. Whereas talking about metrics, they are used for continuous monitoring, trend analysis, and overall system health. So it is more like a middle approach. In a If you talk about a comprehensive observability strategy, these practices are often used together to provide a holistic understanding that we talk about, that why these are the three pillars of observability. Going forward, let's talk about the benefits of tracing. Till now, you might have, you are already clear how it might help. So it provides a comprehensive view. It provides end-to-end visibility, which allows developers and operators to understand the entire journey of request. So there, it's like going through a tag list, and there's also it helps pinpoint performance bottlenecks by showing where delays occur. So it is crucial for optimizing your system's performance. Also, by tracking the time taken at each step of a transaction, tracing allows for a detailed analysis of latency. This is especially important in distributed system where different services may contribute to overall response time. So you know which of these services can cause a delay, and you can rectify it right there. In modern architectures like microservices, which are very prominent, understanding dependencies between services is crucial. So tracing helps visualize and analyze these dependencies. Tools like OpenTelemetry can give you data, and you can take up other tools to create a visualization and see what is causing the delay, where is the delay, etc. So also during incidents or outages, when your application has crashed or is on the verge of crashing, tracing can be invaluable in quickly identifying the root cause. It helps reducing mean time to resolution by providing a detailed record of the events leading up to the issue. Now let's talk about distributed tracing, which is very actively used in a cloud native architecture, and we'll also see how it works. So in a definition, distributed tracing is a method used in software development and system monitoring to track and profile the execution of requests as they travel across various components and services in a distributed system. So in a distributed system where multiple services are working together, because in today's digital world, you cannot see a simple application that has a simple flow. Most of these are divided into microservices. So where these services are working together to fulfill a user request, it is crucial that you understand how each service contributes to an overall request and how this affects your performance, and you have to optimize it so the user can get the whole holistic view of your application and fulfill the purpose or vision you have about your application. So it is also important to maintain the system's health as well. So key components of distributed tracing include instrumentation. In small words, it's like, in simple terms, it's like tracing your data. It captures information about the execution of request, such as the start and end times and any relevant metadata. Then there is trace context. It is a unique identifier that is assigned to each request, known as, you can add as a tag or anything. So these identifier is passed between services as the request flows through the system. Then there's spans. Since we are tracking time, it is important that you add default spans. So a span represents a unit of work within the system, typically associated with a specific operation or function. There's trace tree. The collection of spans for a particular request forms a trace tree. And of course, collectors, which will collect the data about the spans and requests, so you can get an analysis and a visualization. So if you see this diagram, you'll understand that this is how a trace looks like. Imagine you have an application A API, and it calls the service B, right? So this API call takes 10 minutes, and it will have these data sets for example, the work for what request it was, and then it is divided into these data. So this constitutes a trace. The how it is differentiated into different levels. So it takes a whole of 10 nanoseconds or something, and then it is divided into different request flows. In a few minutes, we'll see it in real time, how it looks, and how you can leverage tools to create this for your system. Now, since we are talking a lot about observability and implementing these practices, it is also important to know the challenges that can be faced while we are implementing these practices. So this is not to demotivate or not to propagate that you should not implement tracing or metrics or whatever, but it is always it is always important to know what you can face in real time, because then it would get a little harder. That's why it is told to use frameworks and tools which can make your work easier. So let's take this scenario. So this challenge is known as traced context propagation. The words are quite twisting, but it's fine. So the scenario is, imagine you're ordering a product from an online store. When you click the buy now button, I hope you all are familiar from e-commerce and you buy stuff online. So whenever you click the buy now button, your request doesn't go to just one computer. It's handled by different parts of the online store system. Each part is like a specialized team responsible for different tasks, like checking product availability, processing payment, and updating inventory, etc. So now let's say the online store uses distributed tracing to understand how your order request moves through all these teams. Each team or service is supposed to pass along a special tag or ID, like the trace context we talked about with your request. Then this tag helps connect the dots and show the entire journey of your order through the system. Now, what is the challenge in this whole scenario? So sometimes as your order travels through these services, say each team is handling different services, and one of these teams forgets to pass on the special tag. It's like losing a note or losing your backpack on the airport. That's supposed to be attached to your order, right? So when this happens, the system loses track of your order's journey. The teams can't piece together the full story because they're missing the crucial information that connects the dot, like each step of the process. So this is called the challenge, trace context propagation, or trace context. You can replace it with ID propagation, that it was not followed along through the whole process. Now, what you can do about it? Of course, if there's a challenge, there should be a solution. So it is important. So this is more of a moral, or what you can say, it is more of a qualitative measure. So to solve this, the teams or the services need to make sure they always attach and pass along the special tag or ID as your order moves through the system. It's like making sure there's a note securely attached to your order. Let's say this is the order ABCD or whatever you have ordered, and that some encryption, etc. So it can be traced back. That way, at each step, every team knows which order they are dealing with, and the system can reconstruct the entire journey accurately. In simple terms, it is like creating a pathway or a map to your treasure or whatever. But it is very important, since if a lot of services are active. Now, this is about an order that is a physical entity that you can see and touch in real time. But suppose it is a digital data. It is something digital. It's a digital entity, and the digital ocean is huge. It's endless. It is expanding. It is ever expanding, and there is also dark sides of the digital ocean. So where will you find your data, right? if they don't have a customer support, in a cloud native architecture, what will you do about it? So that's why it's important when you're tracing the requests, you always have this trace context attached to it. So it has to be in the practice, and it is not a quantitative measure. Yes, you can add conditions on the way that if there's no context or there's no trace context in the flow, it should not be followed ahead, but it should be a practice. So that was one scenario. Let's talk about another scenario, or you can say another challenge. This one is an instrumentation overhead. So imagine you have an online shopping website again with various parts that has to be there, so you can have a seamless experience. Of course, you want to use a tool that helps you trace how a user's request moves through these different services to find and fix issues efficiently. This tool, of course, distributed tracing. However, here's the catch. This additional code, since you're adding something to create something, you have to add a code. This additional code comes with a cost. It takes a bit more, not actual cost if you're implementing it, not that. It takes a bit more time and resources to collect and pass around this extra information. In other words, it introduces an overhead. Just like carrying a heavy backpack at a trek might slow you down a bit, this added code slows down the performance of your services. It can make your website respond a little more slowly to user requests, which is not good for a user experience. Of course, this time lag would be in nanoseconds, but over time, it can actually slow down your microservices. So this is called an instrumentation overhead. So what you can do about it? You can another again. This is a qualitative measure. You have to implement balancing act. The solution involves finding a balance between gaining insight from distributed tracing and maintaining fast and responsive services. It's like finding the right balance between wearing a light backpack to move quickly and carrying enough things in it to be well prepared. You have to choose only the critical parts of your code to or optimize the way instrumentation works so that it has less impact on performance. So whenever you are adding, so if you are using some tools or you're using a framework, you are adding traces, you have to make sure that only important requests are traced, and you are not over tracing or you are not creating an overhead, like you are redundantly adding traces or spans on your code, so it wouldn't slow down. Just like this, you can create a balance. Another qualitative measure. These not only these, there are some other challenges as well. First of all, we have asynchronous operations. If you see through these are basically different sides of a same problem. So asynchronous operations can when you have to rely heavily on asynchronous communication, such as message queues or event-driven architectures, tracking the flow of request can be tricky. For example, if a request starts with HTTP request, then triggers an asynchronous process through a message queue, and finally results in another HTTP response. Correlating these events into a single trace can be challenging. Secondly, there's service heterogeneity. Of course, if we have a diverse technological stack, different services may use different frameworks, languages, or libraries. It's up to them, and each service might implement tracing on its own way. And integrating these diverse tracing implementations into a cohesive view can be hugely complicated. For instance, if one service is used Jaeger for tracing and another uses Zipkin, ensuring a seamless and unified view of the entire system becomes a bit of a challenge for all the teams. And of course, we can never forget the security and privacy concerns. They're always there because you're dealing with information, and this can actually have some sensitive information, such as user data or authentication tokens. As a request travels through different services, we have to ensure that these kinds of data are not taken into account, are not taken without encryption and unauthorized access at all. At most of the, with the most of the information should be kept away. So it mitigates the risk of potential data breaches. Now, these are some of the challenges, but these are challenges, but there are also some solutions. It is not to demotivate people to implement observability. It is these tools are used. You can leverage these things. You can leverage technology to your benefit. So we'll talk about a very powerful framework that mitigates all of these challenges. That is open telemetry. So, in a definition, open telemetry is an observability framework, or also you can say it's a toolkit designed to help developers and operators gain insight into performance, reliability, and health of their software applications. These are all the byproducts we have when we implement metrics, logging, and tracing. Also, it provides a set of APIs, libraries, agents, instrumentation, and instrumentation standards for collecting, processing, and exporting observability data. Now, just for a highlight, OpenTelemetry is not a full observability platform like the other ones we talked about in the previous videos, as it does not give you a process. It does not help you to process or store query telemetry. Rather, it lets you collect and export data from applications to various commercial and open source backend. So it it provides pluggable architecture that enables you to add technology protocols and formats easily. So why do we use it? Now we talked about the challenge of what do you say? Yes, service heterogeneity. Say if a lot of services are getting together and they have different implementations, what will you do? So open telemetry standardize these things, and then you can get this data and you can add it to observability platform and visualize your data. So it eases the what do you say, eases the flow, and you don't have to worry about the language you have to use, or don't have. It's also vendor neutral, which means that you don't have to worry about um, uh, what do you say, the language and platforms you use. So open telemetry also can be integrated with a wide range of other tools and frameworks. So that's a benefit, and a lot of organizations use this. Now let's see. It's since it's not a platform, you might wonder how it works. So I'll show you how it works. So go through this diagram. You can see that open telemetry consists of several components, including cross-language specification, per language SDKs, tools for collecting, transforming, and exporting telemetry data, and automatic instrumentation and contra packages. So instead of using different or vendor specific SDKs, you can directly use OpenTelemetry. In this diagram, you can see that the whole process can be replaced, not actually replaced, but can be covered and can be given to the telemetry backend. So you don't have to worry about which using different platforms or languages. You can use OpenTelemetry directly. No wonder if you had different, you're not using OpenTelemetry and you have different services. The permutation and combination of these things can drive you crazy. Now let's see what it looks like in real time. Yes. So this is, yeah. So as I said, you can implement, yes, you can implement OpenTelemetry with a helper backend. So I'm using Jaeger here. You can use Zipkin, Prometheus for different things. It's up to you. So I've created, this is a simple video catalog application. I added some of the open traces in here. So, and in the code, and that's what it's tracing. So you can see here, like at 7:48, I refreshed this last. Let's do that again, and you'll understand how it works. Yes. So it might show up here again. Okay. Yes. So yes, in here I found a trace again, and it said 829. I refreshed it again. It refreshed all the services in this application. So let me see if this videos API works. Yes, you can also filter this with Jaeger, and you can filter at okay. Right. So I have this get request, and you can see in real time how these traces look. So if you ever find a delay, it will show you that yes, this particular request was taking a little more time than intended. You can add a span. There's this library like open traces that you can add into your code, and different what do you say objects of this library help you to track your request. You can see how ramified this is, and at different spans, this is the whole request, right? And different parts of you can also see how different parts of this request look. This to 16 point okay 7 is microseconds, and then there's ramified data like this particular request in under this one took this much time. So if this particular time goes beyond the span that you have intended to add, it will show you that this particular is your bottleneck, or this particular request is taking a lot of time. So you can see what code is actually creating this delay. And if you so this particular application or tool or whatever API gives you this at different time. Even if I like want to upload some of the data, I can add it here, and it will visualize that as well. Since I have okay, this is the graph. Okay, you can also see the graph here. Let me see what it looks like. You can also filter it according to your services. But also here, if the code is huge for this particular application, the code is huge, and if I have added a lot of requests, say I have added for each trace, it would be a lot of data here, and going through that would have taken a lot of time. Even if it takes a lot of effort to analyze this. So there's a filter here as well. You can use it to see your data. Okay, let's do that. You can also okay, so it's not creating a graph right now. No problem. You can also see what kind of request it was. So whenever you're using some applications like Postman or anything, you can check from there if there's an endpoint that you cannot connect to. You can hit that endpoint, and you can replicate that request as well. So that's how you can rectify what's going wrong, and you can have a clear picture of your application's flow. All right. Well, this is nice. So that was particularly about tracing and observability, how it looks like. and how you can implement it with help of tools. So not particularly into the code. If you want to check out how you want to add it in the code, you can also you can check it out. And if you want me to create content for code creation, you can also add it into the comments or suggestions. And next Tuesday, we'll talk about alerting and distributed context. Also, some other aspects of observability. So, if you like the video, please, if you like the content, please like the video and subscribe our channel. And if you have any suggestions, you can connect directly to me through LinkedIn, or you can also join our community on Discord. So that was it, and I'll see you next Tuesday, same time. Thank you.